This is Leading Detection, a Sedulo podcast where fraud fighters talk tech. Welcome back to the Leading Detection podcast. And today we're joined by Eugeny. He's building LLM products at SUMSUB. The podcast is how we leverage technology to fight fraud. So who better to talk about reality and hype in AI and ML in fighting fraud? Eugeny, thank you for joining us.
Hello, Matt. Thank you. Yeah, that's true. I'm working in SUMSUB. I'm building the AI products. I'm head of our large language models team. And yeah, it would be great to discuss what's going on here in the front landscape. Because like the last years, we have a few movements and trends with general AI, which really shapes the landscape. It's still not yet finished. We are still in process, and that's why it's so interesting.
Yeah, well, maybe we start with a bit of a reality check. ML in fraud prevention, what's actually changed? What's mostly hype?
We have a fraud report being published every year. So it's relatively easy to me just to check the few fraud reports and bring this all together. And a few years ago, we started to see a new trend, which we call the democratization of a fraud. A few years ago, fraud tools turned from, some very technical skill and you need to be a really educated person to run, custom Photoshop to edit the document or some custom stuff to really break the system. 2 years ago, it became highly democratized. You don't need to be an educated person. You can be every person with a very small investment of few $1,000s. You can end up with a fully built, prepared software, customer grade software, just to make a fraud document, just to make deepfake videos of liveness authentication, to spoof your camera network, to do all that stuff. But it was a few years ago, and it was kind of a new thing, but we found how to fight it. And right now, what we see, we still have this huge volume of fraud attempts going on, but right now it's a backup. It's something going on a phone. What we have a huge trend of sophistication of a fraud. This is the last year invention. So we still have this democratized frauds, but these people who got the software, they started to educate. They started to make more and more complex fraud attempts. So right now we have this big noise of democratized fraud plus some sharp attempts, sharp deepfakes. And sometimes it ends up that you can lose, a few dozens of millions of dollars due to one deepfake call with your video operator.
So there's a lot of this going on. There's a lot of reality about what is actually happening in the real world. But what about hype? What is maybe being sold to us or creating fear around the space that isn't really happening?
There are a few things. It's, as with every hype, it's pretty hard to differ. What's right now sounds like a hype in a year became a reality. So what's going on? From attacker side, there are a lot of attention to AI fraud agents. The AI agent, which goal is to bypass a system, and this agent tries in a cycle like dozens, hundreds of times, trying different ways, trying the different parameters, breaking the system in a cycle. That's still a bit of hype. Right now, we have it only as a proof of concepts. Of course, we have our own red teaming initiative, and we try to build this stuff. And as we may see, and as the sources on internet, you also may found that it's still a proof of concept. It's still not a working prototype. The modern system can block this agent much easier than a human, but it's only for now. Who knows what will happen in a few years? And this is a big hype from attacker side. And of course, from defender side, the big hype, I can call it the AI washing. Once we talk about fraud, the thing I will bring throughout all my speeches, we are talking not about the single model. We are not talking about some foundational AI model. We are talking about the system of different models, rules, and humans in the loop. And it's not a Gen AI. It's not some perfect God blessing AI that save us out of fraud. No, it's like 100 of models designed, engineered, deployed, continuously improved and integrated. It sounds not so fancy, not so glamorous, but okay, that's the reality.
Yeah, the answers that are successful mostly aren't sexy, aren't interesting. It is the boring stuff that does the lion's share of the work. But machine learning within fraud in particular, where are you seeing it work best? And maybe on the other side as well, where is it falling short?
Yeah, there are a few different slices of this question. First of all, there are types of tasks the machine are already much better than humans, and human can't fight this thing alone. For instance, for good and complex deepfakes, right now, the models works better than you and me. Seriously, the models right now differ the deepfakes images, especially if it talks about very specific image, like for online KYC, you need to generate a face and a bit of a background. And the models goes much better than people. And it works good, first of all. So there are different tasks. Another story is that, thanks God, we still have some space to improve because the generator models, they are trained to fool the human eye. They are not trained to fool the machine. And the fraudsters, they do not train their own foundational visional models. They use the freely publicly available one trained for legal purposes, like, content creation. I think you know better than me. Yeah, they use the same models with some additions. And these models, they are trained to fool the human eye, and we still can catch these models in some very small, the background noise, the artifacts somewhere when you never see it, like somewhere there. Yeah, something like that. That's the first part. Another part, you see, there are models and there are not models. There are rules, there are backend code, and there are database checks. And sometimes this database checks works much better than models. Okay, you can fake the tax number declaration. But if there are a database where you can check the tax number and compare it with a name provided independently by government organization, okay, good for you. You fake the document. We checked you on another step.
Yeah.
And also with the humans, when we talk about hard fraud schemas or anti-money laundering schemas, when we talk about fraud rings, the human analysts is the first-class citizens here. So we can say that at some very hard cases, our models are not used to stop the fraud directly. They are used to highlight the suspicious cases, to highlight the strange patterns, and to make the human analyst a superhuman, to make him able to, or she or he, make this person able to solve, 100 cases a day instead of 10 cases. So you see, all this stuff works together. We use the machine learning models in places when we are not able to catch the fraudster by human eye. We use the rules and database checks and the backend business logic in places when we have the ability. Mm-hmm. And we add the human layer analysts to keep the rest.
Yeah. And obviously machine learning is used worldwide, but specifically looking at fraud, why does using machine learning in the fraud domain differ from using it in other industries?
There is a difference, but the difference lies not in the models themselves. I worked throughout the different industries. I spent a lot of times working in recommender system. I worked a lot with advertisement, even with a code generation routine a bit. And what I can say in fraud prevention, the models are the same. We still use the same level of models. We still use the same computer vision models. We use the gradient boosting decision trees for classification. We use, large language models for data instruction and data transformation, data preparation. So it's all the same. It's not a problem. But what differs? The difference is that in a fraud prevention, it's a pretty close domain. If you go to academia, if you go to public speeches, there are not a lot of in-depth stuff. Comparing to recommender system. But a recommender system is a huge piece of commercial secret, huge piece of your profit for a company. But fraud prevention even worse, because it's not only a commercial secret, but it's also a secret for fraudsters. Like, I can't publish a data set, or I can publish a data set for many reasons, starting from the fact that most of our data sets, this is a private classified information, maybe even PII a bit, photos of people. Of course, I can't publish it. I can't publish an article about how my models works in depth, because right now, as I told you before, the fraudsters became more and more educated. And the most educated of them, they can just read an article and make a generator to fool the model. You see, so we're living in a place where, like, it's hidden.
Yeah.
There are no the domain knowledge, the tribal knowledge of fraud experts.
Sounds like a triple threat, right? Because you've got your commercial interests, of course, as a vendor you need to protect. You've got the governance of the data from your clients, and then the security of putting your information out there to be leveraged in ways that could do harm.
Yep. And that makes a difference, I think.
So you touched on it. If we go kind of going back a little bit, you talk about building the systems, you mentioned rules, machine learning. There's also graph analysis and, of course, human review, all parts of the equation. But how do you decide which tool for which problem?
I'm very glad that you asked. Welcome to my course of lectures. In fraud system design, lecture 1 out of 20. Let's start.
Starters lecture. Intro.
Yeah, 101. You see, like, of course. So, speaking frankly, why should I choose? I want all. I want all of this. And this goes like an escalation ladder. I mean, like, imagine that there is something like 2004 and you are starting. What you have, at the best case scenario, you have rules. The rules are crafted by knowledge, not by data, because you're still yet not very familiar with data analytics, and you have a lot of people to work with your alerts. Why am I saying about 2004? Because, like, I think right now there are no company in the world with such setup. 2026, but 20 years ago, there were most of them that were on such setup. So what would you do? You would start with the rules. Because, like, first of all, it's easier. Second of all, it's much controllable. And third of all, it's more explainable to our business owners. You just go with the rules, but you turn your rules from just a knowledge into a data-aligned process. You take the rules, you design the rule system, and you start to tune your thresholds based on the data, based on false positive, false negatives rates, fraud acceptance rates, and so on. At some point, you understand that you are done, that you made all the hardest rules you can imagine, and this rule still a bit fails, and this rules works not in a system but one with one. You want to make a synergy of these rules, and what's the synergy of the lot of ifs? Yeah, I am describing a decision tree. There we go to gradient boosting. If in a better version of decision trees, here comes the simple machine learning models. Of course, if we add the computer vision, we will end up with the neural networks. If you have a computer vision part in it, now we are somewhere in 2018. Yeah, and once you finished with this, you're going to your understanding that okay, I have this one, but the cases are still growing. I need to compare my session to the previous one. There comes with some learned embeddings of a session. You go to a graph analysis, and you said, and it's still yet not enough. The fraud continues to grow. The new types of pattern exist. So you decide, okay, I need to make a human in the loop pipeline. I need somehow to assess my data and assess it targetedly. Maybe I need to work with the confidence of my models. Now, maybe I should research the field of uncertainty estimation. And after that, you're ending up in some more or less modern setup when you have a bunch of different models working together. You have a human analyst to, first of all, review the hard cases. Second of all, to label your data, actually. And this system working together, a set of AI models combined together with a human in the loop, with a continuous improvement, this is the end of your escalation ladder.
So is a human overseeing all this, or are they part of the process?
Yes and yes. Sometimes they are part of a process. Sometimes they're overseeing it. And the best case scenario, it's both. Because even the easiest model, even the rule systems, they may fail because the trend changes. You know, like referring back to, I forgot the joke I prepared. Referring back to what's the difference from machine learning and fraud prevention against the different domains. You know, when you try to detect a tumor or a cancer, the cancers themselves do not mutate because you change the detector. The fraudsters mutates when you change the detector, you see? So
it's a living thing. It's day by day. But is that shortened now? Maybe the types of fraud evolved every couple of years, couple of months. Are we now seeing it hours, minutes even?
Still not yet minutes and still not yet hours. I can say it's close to months. Plus, you see, there are a conception of how much money should you put to fool the system. So if you have like company named A and company named B, and the company named A created a fraud detector like 2 times better than company number B, the fraudsters just may flow to company number B until they catch up with the market. So that's why it's not an hours. So the fraudsters goes between different companies. They are trying different ways to fool the different companies. So it still takes in months, but it's pretty fast. Cancer is not mutates in the speed of process.
Not that quick, certainly. So with the machine learning, the graph analysis, there's a lot of models, a lot of data. What's needed here? What would you prefer? Better data or better models?
Of course, there is no difference, you see. For me, it's of course a better data. I mean, like, as I told, models are pretty standard. There are no specific fraud prevention. Okay, there are a few tricks, but the tricks are not the key difference. They are not stored secretly. You can get it. And the data, of course, is the most valuable asset. The data and the feedback loop, and even, even not the data themselves, but your ability to build a pipeline to make your data discovery targeted, to make your data valuable, not to spend your, let's call them moderators, but it's a very big range of different anti-fin crime specialists. Just for easiness, we'll call them the moderators, not to spend the time of your moderators of simple, easy, same-shaped false positive alarms. Just make them targeted.
Yeah, so I mean, data, there's prediction models, but data is usually looking back. So how are we catching something new, but catching something new without, like you say, triggering those false alarms and without crying wolf all of the time?
Know-how. It's not a question of, it's a question of point of view. You have a lot of people, some amount of people, which are trained and qualified to label the data. And this is only question for you. What's you're sending to them? Are you sending the false alarms, or are you sending the valuable data assets you can turn into a new model, into an improvement, into a new step of the system, maybe even a new whole system themselves? And yeah, of course, if I come to our moderators and say something like, folks, hello, I have another 5% of stream for you to label. They say, like, Zhenya, are you mad? We have no time. Go away, please. So I do not come with this type of communication. I come with a deal. Okay, my friends, I see you're spending a lot of time for the stuff I can automate. Right now, we can automate the work for many different ways, starting from a rule, ending up with large language models-based agents. So I can save you 5% of your time. Could you please spend this 5% to my data stream? And this is the art of a deal, you see, because this automation buys your time of a moderator, the time of a moderators buys you more data labels buys your better models buys your more automation.
And are we you talk about time, but are we actually cutting losses in this process, or are we just keeping up but adding friction at the same time?
We're doing both. Of course, there is a trade-off. You know how to block all the fraudsters from your bank?
No new
A
customers.
seamless decision. Just close the registration form. No users, no fraudsters, no problems. You see, so in a limit question, yes, of course, we can just close the doors and there would be no fraudsters, of course. But when we're talking about cutting losses and adding more friction, we can reform it into fraud acceptance rate and approval rate terminology. And this translates into proper normal machine learning metrics. It translates into precision under fixed recall. We want to catch as much as possible fraudsters to keep the approval rate as high as possible, caching the sufficient amount of fraudsters on the same model. And we have the system multiplied for different models. So even 1% of 99 of recall, 1% left, but it means that another model will catch it because we have it as a pipeline, as a filter. But that's a mechanism for you to evaluate and decide on an offline modeling. You have one model A, model B, you calculate the precision under fixed recall, you have two numbers, you may decide. Pretty obvious. But the problem is my salary is not paid from precision recall curve. It's paid from company profit.
Yeah.
Another problem, the company profit is not a smooth metric. I can't put this metric directly into a model.
No.
That's a problem. I'm still thinking how to solve it, but
you have to let me know when you solve that.
Yeah, but in the meanwhile, there is another trick. Company profit goes better when the quality of a fraud detection model goes better. That's why there is a proxy. Proxying the company profit with precision and recall. But we understand how to measure precision and recall, but how to measure the quality of a proxy. The proxies themselves. My idea that the company profit is somehow connected to precision and recall. I need to test it. Thanks God, here in a fraud prevention, it's not as bad as in a recommender system, for example. There are no interconnection between A and B groups. There is no homogeneity effects, graph-based effects. They are pretty low. So what we do, we can start from a shadow mode. I have a model A and I deploy the model B to production and just calculate this two different scores and two different decisions, and I can compare it like in a real time. What will change if I deploy a new model? If I deploy a new model, what will happen with approval rate? What will happen with automation rate? What will happen with the amount of new potential tasks being created? What's the quality of those tasks? Do they differ from a previous model or not? I think that the second version of a model should somehow be aligned with the first model. Yeah, the people who sent to review, they should be pretty the same. Maybe a few more there, a few less there, but pretty the same. This is the second step. And the third step is a classical A/B test. Like once you decided that, because why do we need the A/B test in this setup? The shadow mode answers what will change with what will happen with our business value if we change the one part of a pipeline. And the A/B test is the integration testing. How this change of one part of a pipeline works all together with the old bricks. So 3 steps, 3 gates. Offline testing, shadow mode, online testing, and you're good.
Yeah. And so it is all about moving forward and improving. And if we to now look forward, maybe call it the AI frontier, about products, demos, putting those into production and kind of where generative AI fits in as well. So from your perspective, what would you say separates a good demo in the fraud space from a system-ready product for a regulated environment?
You know the difference between demo and regulator review. On a demo, you pick the samples. On a regulator review, the regulator picks. So this is the answer, actually.
Yeah.
I mean, like for a demo, it's okay to work sometimes. It's okay to work in one part, do not work on another part. Like it's totally okay. When it comes to regulated environments, okay. And if you open the regulations, first of all, like my condolences. Second of all, if you open the regulation, you will see that we do not have only requirements to be precise and to be full, to optimize our precision and recall. We also have to be requirements to be fair, to be unbiased, to be explainable, to be a lot of stuff. And you need the evals. You need a lot of evals to guarantee that you work. And even if the regulator comes, like if you have a full-scale guarantee that your model works on 99% and you understand that it's enough, and very good point to compare it with a human. I have a human error rate. Human makes errors, but we trust them in regulated environments. And this is our baseline. Like should compare yourself with a human. When the human works and when the human fails. Could you determine the situation when your model fails but human works? Could you transfer these cases from model to human? And this is a question you need to answer when you want to deploy, and it goes to everything with the evaluations. And first of all, the initial evaluation, second of all, the monitoring. Actually, there's been an article written by Google. 10 years ago. I will send you a title. It's like explains everything I'm talking today. It's called like Hidden Technical Debt in Machine Learning. And the folks from Google, they just show that in modern machine learning mature ecosystem, the modeling themselves takes about 5% of your time. And 95% is infrastructure, data loops, tracking, monitoring, improvement, detection, continuous integration, continuous deployment, and all this stuff. Am I said about it? I love modeling.
Yeah.
Does it pay me salary? Yeah.
And is this coming back to the boring parts that are the most important?
Yeah. Unfortunately. Maybe because it's most important, it's called boring.
Yeah, most likely. But when we are going from demo to the real world and we're scaling, what is it that breaks? Or what breaks first?
What breaks first? I think, I don't know. Because what breaks first, if I know what will break first on a regulatory review, I will fix it in advance.
Yeah.
I think most of the time breaks something you didn't put a lot of attention. I mean, like some small piece of your pipeline, you think that it's working good, it's been working for a few years and it's okay, and now you goes under the high and precise review and it breaks. That's why it's pretty good to keep this thing running, at least in the terms of like continuous evaluation. For instance, when we talk about the different large language models, especially right now, when you're using the providers, they mutate a lot. The providers mutate, they change the version. Sometimes it's happened nightly. I mean, like in the middle of a night, no one been acknowledged. It happens. Maybe not for a bad will of providers, but this is how the industry goes. It moves very fast. And we have a continuous evaluation of all our providers, just to understand what's happened. We have a few providers, we can transfer traffic from one to another. We have even a self-host version, we can transfer traffic to the self-host version, and we compare our providers one against another, like every day.
Yeah. Well, when I asked that question, you said something that LLMs don't usually do or don't do. You said you started with "I don't know." So a lot of the LLMs can be confidently wrong, right? So how would you reduce that risk? Is it ever going to be zero?
First of all, there is no zero risk. Like everything I'm talking about, like, the machine learning is backed by probability theory. And when we talk about probability theory, there is no zero risk as such. There is very low level of risk, but it's never equals to zero. And that's the thing I need to, to talk with my managers every time, to talk with the product folks every time. There is no zero as such. There is always a probability, but we can reduce the probability. And what's about large language models? First of all, it's a good thing if there is what saves us from a problem? It's much easier to critique than to build a thing. I think as a content creator, you know this problem. It's much easier to criticize something. But in the case of large language models, it helps us. We can check some parts of large language models answers by a raw business logic, by raw rules, by raw ifs and string replacements and regular expressions and all this stuff. First. Second of all, we can, at some point, the model knows, is it confident or not? Like, you're trying to get the answer from your model and it answers like yes or no. Is it fraud? Yes or no. But if you look deeper, if you look inside the model, if you look at the model weights, if you look at the model probability distributions over tokens, you can end up to understand that it's not yes or no, it's yes with a probability. And there is a works you can translate these tokens distributions into some confidence score. And at some domains, if you have a well-formed task and you have a good data sets, you can calibrate this model's probability into uncertainty score. Translated from yes to 0.6, 0.9, and 0.9 is good, and 0.6 it's not very good. It's still yes, but maybe not correct. This is another trick you can do. It's like, it takes relatively long time to develop. It's not possible to do with all providers popular right now on the market because they close this API, but it's possible. And last but not least, they may sound confident, but at the end, we want our models to be correct, not as their sound, but as their decisions. So if you add these pipelines of multiple checking, uncertainty estimation, maybe some human review on uncertain answers or another types of review, you will end up with more or less close to zero, but still probable risk.
Yeah. And when we've understood the risks and kind of know how to harness it, where can we use LLMs, generative AI agents within the fraud detection space to add real value? And where should they, at the moment, maybe not be trusted?
First of all, it's like turning math into structure. I say that if we talk especially about generative AI, they are best of turning the anti-fin crime specialists into superhumans. Like, they are very good to analyze like 20 pages PDF with a company structure into normal graph of ultimate beneficial owners. Classical task for know your business. Yeah, they are very good to like our like classical task. We are checking the documents, and the problem is that there are about like 250 countries and territories in the world. Some of these countries, like USA, they have the states. Any state in any country have their own design. They change these designs once half a year, maybe somewhere in the world, someone changed the design of a passports or national IDs or driver licenses. And this is a huge stream of unstructured data. And what you want to extract, like when it was made, what's the name, what's the number, what's the date of expiry. In this kind of task, Gen AI saves a tons of time, and it's really perfect. And last but not least, sometimes it's even helps you to configure the environment, at least to make an initial configuration. I love the features we have in SUMSUB. Like we have a transaction monitoring solution, the transactions, the goals, you have a rules, you have a machine learning, you have a case management theorem to see the alerts, and you need to configure it. And what do we have? We have a huge big data model of what the transaction may be, and we have the rules. And it's kind of hard to configure it. You need to learn a new system. But we made our AI rule generator, which took your requirements and turned it into configuration. Yeah, it may make mistakes, but at least you have an initial setup and you can look at it and you can review it. And it's much easier to criticize than create, you remember?
Yeah.
Even for a human.
And where it shouldn't be trusted just yet? Or is that what you mean?
It's still good to oversee, especially if you are in a regulated environment and this setup of rules. It's like the questions the regulator may ask you. Yes, of course, it's like they are making mistakes. You know this phrase. So yeah, of course, it's better to oversee, but it saves a tons of time.
Yeah. And you're of course, if we're to look ahead now, you're a big advocate of machine learning, obviously. What do you, from working within the fraud space, what do fraud leaders and machine learning teams often misunderstand about each other?
Yeah, a good question. Good question. What do we misunderstand? For machine learners, I think this is a domain. The machine learning, this is a domain, like not all errors are equal. Some errors are okay to go and some errors are critical. And this is a pure domain knowledge of fraud experts. I am not as good as my product folks in anti-money laundering routine and transaction monitoring and travel rule crypto regulations. It's just a lot.
Yeah.
And this is a thing you always need to be in touch. Like, okay, I made a classificator. This classificator, 95%, it's totally okay. But this classificator, it's not okay. We still need to think. We still need to improve. We still need to push it. That's from machine learning side. Another story, it's like the friction is the real money, especially when we talk about the access to financial banking applications, stock exchange. Your 0.5% of approval rate drop turns into thousands of people who are just not able to manipulate their money. This is also a situation. Like, it's much better to roll back than allow this thing to happen. And another story. And what's about the fraud leaders? What's about fraud leaders? First of all, no zero fraud. I mean, like, any model is brilliant. We are living in a situation when we have a probabilities and we work with the probabilities. And it's very strange when you say, like, okay, I have a model, this is a report, this is the risks, we calculated the risks, we transform this risk into money, into precision recall curve. We said, okay, I deploy the model, the day after, it fails. Here it fails. One single case, it fails. Okay, but what's the numbers? Like, is it more than we expected? Is it less? No, it just fails. It's just one single case. Fix it. How? I think it's a hype. You see what's the problem? Right now, the large language models, they works as like the level of interest is very low. You can, you can run your own agent like in the evening. The API is available. The API is simple, just a post request. And when you try to do something, like 80% of cases would be working. Right now, building the first step, building the 80%, it's like so easy. Like it takes a minute. So the problem with fraud leaders that they make some prototyping, they vibe code something, say, oh, it solves the problems. It took like one evening. Let's go to production. And it's like, okay, what I will do is another 20%. You understand that the rest of the steps, they are still the same. There is still this 95% of infrastructure deployment, improvement, evaluation, so on and so on. Yeah. And this is a problem. I think this is a problem being created in the last few years with like huge hype over the generative AI.
Yeah, and bring that all together when you are hiring for machine learning talent within fraud prevention. What do you think is actually important for hiring in this space?
There are a few options. First of all, you found a guy with domain knowledge from fraud fighting company, which good fits into your corporate culture. Like you're lucky to go, just hire it and forget. All good. Yeah, but the problem is, as I said, this is a closed domain. And it's normal, but the models are the same. The methods are the same. There's a lot of things from different domains applies to fraud prevention. That's why it's totally okay to hire a person from another domain, like from advertisement or from recommender system, and push the person into fraud prevention ML domain. It's totally okay. But first of all, you need to know that there is a domain tribal knowledge and you need to share it. That's why you should be prepared to share the knowledge with the person, first of all. And the second of all, what I like personally, you see, like with the I think I've read an article that right now we are moving from big teams into individual contributors. Right now, when the building is not a problem, when you have like tons of AI coding agents under your fingers, it's not a big question how good or fast in coding you are, but the question is how good and fast in a task definitions you are, how good you are in your ownership mindset, how good you are determining what we told in the previous point. Do you understand that your 0.5% of false positive drops is actually a conversion? Do you understand how to measure it, how to make this connection, how to make these proxies? So this kind of product-oriented ownership mindset is what I'm looking when I'm doing hiring.
Okay. And is there anything that's overrated skill-wise or expectation, responsibility-wise?
Overrated? I don't know. It depends on your, like, I think there is no one thing to be overrated. I've seen the different types of mistakes time to time. Yeah, I think right now it's not there's no such one big thing.
And when you are hiring, you mentioned about sharing the knowledge, not necessarily coming from fraud prevention. On average, what would you say the kind of ramp up period would be from if you hired someone from advertising, machine learning, you brought them in for fraud prevention? What kind of timeline would you expect for them to get a good, solid understanding about the domain?
This is a question how good your onboarding process is. I mean, like it may take from months up to a year. But what I love to do, I love to give a first tasks pretty well defined in a smaller domain, like not going to our system as such at all, analyze the system, find the weak point and fix. No, thanks, please, no. You need to have some domain knowledge for this type of job.
Yeah.
But if I know that, okay, our data extraction pipeline is not ideal. This is a very simple piece of task. Like just look at this, find the problems, fix them, bring the fix, deploy it, track it, and let's go. Okay, the next task. We have the question about our computer vision models in this concrete domain, like 1 of 10. Let's go with this one. The person picks. Okay, and the next story is about a bit harder. Like we have a complex analysis tasks, we have a set of bunch of rules, and we need to make the analytics suit to understand how good they are or how bad they are. This is more complex. So step by step, and I think in like months, you will end up with a fully educated person. But also it depends on many things. Like the simple question, like how easy is to push a code to production in your company? If it takes a week, the onboarding will take half a year. If it takes a day, the onboarding will take like a few months.
Yeah, good perspective. Good perspective. I think that's a good point to round us off. It's been deeply insightful, Eugeny. If people wanted to hear more from you, understand what you're up to, keep up the work you're doing, where would you recommend?
Have my LinkedIn, for instance. I'm publishing all my public activities there, and we have a lot of stuff being done by SUMSUB. A few last months I participated a few events personally, plus my colleagues also do. We have a lot of talks about fraud prevention, AI agents in machine learning, in finance, different industries. So you're welcome.
And one final question, what are you excited about in the space for the kind of second half of the year? Putting you on the spot there.
Yes, what it mean. I'm waiting to things to become better. I seriously waiting. I have a lot of stuff being buried for some time. My favorite story also mentions the AI rule generator. We prepared the prototype of this product like 9 months before we publicly released. I made the prototype, but the models were not good yet. And in a 9 months, I've done relatively nothing with this prototype. It's been an internal usage, but it made mistakes, made hallucinations, made stuff. And in a 9 months, it turned into a good product just because the model became better. The version grew, the hallucination reduced, the long context became better and better. So I'm waiting for what's new would emerge with general AI capabilities continuing to be more and more robust and efficient. What's real thing will emerge. But you still need to differ the real thing from a hype.
Yeah. Well, patience sounds like a good skill in the space. Evgeny, it's been an absolute pleasure. Thank you for joining us.
Pleasure for me too. Thank you.
Awesome. And to listeners, until next time, ciao for now. Want to hear more about fighting fraud with tech? Subscribe to Leading Detection wherever you get your podcasts.